Hey everybody, welcome back. This is going to be the second session of day 2. We're finally through the spanning tree section. I know we went through a lot of different details and I gave you a lot of scenarios. I hope you weren't overwhelmed. There's so much to show you, and I've got a lot of knowledge of spanning tree. Like I said, I didn't always appreciate it early in my career. It wasn't until I started seeing customer environments that were misconfigured, and I was like, wow, I can really make a difference. And they don't have to buy anything, and nothing's broken, at least in terms of what the customer sees. They think it's fine because they can ping everything, but if you look at what's happening with their traffic, it's not so great, especially under high utilization. So you could go in there with this strategy, tweak spanning tree, make it run a little bit better, and the customer didn't have to spend any money. They just had to, or your employer didn't have to spend any extra money outside of sending you to class, of course. But you can come back and take the equipment that you already own and use your skills to make it work a little bit better. So that's kind of cool. It's like when I see used to be into Corvettes, and there was a guy locally that had a dyno, and he had a computer system where he could reprogram the ECU. So you could take a car from the factory, no aftermarket air filter, no exhaust or headers yet. I mean, if you've got that stuff, great. But you could just take a factory car to this guy, and he would throw his tune on it, and he could optimize the car from the factory tune. He was that good. So I always respected him because I was like, wow, he knows how to do it better than the factory. And he was so humble about it. He's like, well, he's like, the factory's very conservative, and he's like, all the cars, even though they try to make them the same, and they come out a little bit different. So it's a safe kind of default tune. And then he'd go in there and optimize it a little bit. So I kind of saw myself as wanting to become that guy. I wanted to be able to sit down and know the hardware well enough that, if there's a guy out there that can tune, Mustangs or Corvettes or M3s, like I want to be the guy that could like tune the router and get a little bit more performance out of it. So that's how I started looking at spanning tree. And it took it, for me, I thought it was the most boring subject on earth. And I had to learn it. And then once I started to learn it, I was like, oh, this is like, there's a lot to this. And then I started to look at, some different customer networks. And the first few that I looked at, there wasn't much to do. But once I did stumble into an environment that wasn't really properly configured, it became pretty awesome. One of the things that I mentioned in the last section was if I had 4 links between 2 switches, that's great for redundancy purposes. I could have a physical wire fail, and then it would switch over to the next wire. And then maybe a physical Ethernet port fails, and then it moves over to the next wire. And basically I could keep having failures and keep having backups. But under normal situations, and I don't see a lot of failed, short Cat5e cables, and I don't see a lot of failed Ethernet ports unless there's lightning involved. Under most scenarios, when I've got those 4 wires there, 3 of them are going to be blocked and only 1 is actually going to be forwarding data. So that's kind of miserable. One of the things that we can do is create an Etherchannel. As I mentioned earlier, we can create a logical interface that consolidates all those physical ports and lets us perform load sharing across all of them. Now, we're going to talk about Etherchannels in the next section, which is imperative that you know this for IC&D too. It's a big part of the class, and it's important, not only for the exam, but it's something that we use every day. I'm also going to introduce a topic that is not in the course, and technically it would be a CCNP topic, but they don't even talk about it in CCNP yet, and that's something called switch stacking. Switch stacking is where you can take multiple physical units and combine them together, kind of like if you've ever clustered SQL servers where you've got multiple databases and they're all working together as a team. You can do that with your switches, and then you can do something called multi-chassis link aggregation. So I'm going to show you what you need to know. I'm going to show you the regularly scheduled programming, which is Etherchannels, and then I'll probably spend about another 10 minutes going above and beyond showing you stacking. Stacking is something I see in every customer network that for some reason, here we are in 2014, it is not covered in Cisco's curriculum yet. It is in the data center side, when you start taking the Nexus classes, but it's not in the Catalyst courses. They're going to fix this in the new revision of CCNP switching. You'll start to see stacking there, but it's nowhere yet. So we're going to cover it just so that if you see it in your topology, you know what's happening. Or if you're making purchasing decisions, you can make better decisions because you know what this is. I feel like it's fundamental to switching and link aggregation. So If I get into it, I'll probably give another disclaimer that says this isn't on the test. So if you want to shut it off and not know any more facts, that's okay. You just come back and watch it later. But I feel like it's something that most of you are going to want to know about. So let's go ahead and get started by jumping into the Etherchannel section. So the need for Ether channels, well, links get congested. You know, if I've got a 1 gigabit per second switch and I was only using a single link, I'm only going to get 1 gigabit per second. If I use 2 links, like you see here, I'm only going to get 1 gigabit per second because those links are in the blocking state. If I was to go further and add 2 more links, how would this affect my bandwidth? Anybody? If I double the number of cables, Mark says it wouldn't do anything for me, and he's right. What a waste. So we can increase this by getting spanning tree out of the way. Spanning tree says there's multiple paths to get there, so we have a loop. And I say, you know what? Bundle these together and see this as one logical path. If that's the scenario, now spanning tree is not going to mess with us. We've got higher bandwidth. We've got load sharing, not load balancing. That's one of, as I think Todd mentioned earlier, he said, I saw your name as one of the technical editors. I work for Cisco, I work for HP, I work for McGraw-Hill and Singris as a tech editor. When someone writes a book, they hire me to go through it and find things that the author said that were right or wrong. And I try my best to catch everything, but you do what you can. I haven't heard any big complaints yet, but it's a good way to kind of fact check yourself and see what you think you know. A lot of authors out there use the term load balancing. Now, F5 makes a load balancer. Citrix makes a load balancer. Radware makes load balancers. Barracuda makes load balancers. Cisco does not. They used to have a product called the Ace, but it wasn't that good. And if Cisco can't win, they don't play. So they discontinued that product, and they don't actually make load balancers anymore. Well, wait a minute. What is load balancing? Load balancing means a packet comes in to a device, and the device is smart. And when I say smart, it means he understands what the load is, right? He's load balancing, so he sees load as a percentage of utilization. If he sees one device is at 33% and one device is at 40% utilization, he steers the traffic towards the device with the lowest load. There's intelligent forwarding decisions being made based on load, so we call it load balancing. Mark says like an SBC. I'm not sure what SBC is. But then you'll probably spell it out and I'll go, oh, of course I know what that is. But right now, I'm drawing a blank. Todd says, why would someone use spanning tree over rapid? It's because it's the default. People love defaults. And that's your default. It's less resource intensive, which is why it's a default. And rapid spanning tree has lower convergence, but higher resource utilization. Good question. Coming back to this, a session border controller, that sounds like it does the same thing. I'm not familiar with those, but it's probably something real similar. What we're talking about here is not any of those things, though. It's not load balancing, it's load sharing. Load sharing is so simple that it basically looks like this. An Ethernet frame comes in, we can look at the source MAC address and the destination MAC address, right? Now, just imagine all I was going to do was add those two together and come up with a total. Because it's a 48-bit value and a 48-bit value. I could convert those to decimal, binary, whatever I want. I could combine them, and I could come up with something that is odd or even. You guys follow me? Source and destination MAC address, add them together. What's the total? Odd or even? If it's odd, take port 23. If it's even, take port 24. That's not exactly what happens. There's a different logic within the switch that has to do with a hash table in hashing source and destination MAC addresses. But that sounds fancier than it really is because it's only as smart as this. This is a dumbed down explanation of what a switch does to perform load sharing. He just looks at packets or frames, looks at the source and destination MAC addresses, and goes, these packets go over here, these packets go over here. So in a port channel, if all the traffic is happening between two users, you have 100% of your traffic on one link, 0% on the other link. You could have a second flow come up. So host A was talking to host B. It went on link 1. We'll call these links 1 and 2. Now host C is talking to host D. Based on the outcome of this MAC hashing, he also goes on port 1. So there is no analysis of what does our current utilization look like. We just bring frames in, we've got multiple paths, we flip a coin with no intelligent logic, and we pick a path. You guys okay with that? That's a difference of load sharing versus load balancing. Most devices at the network level are doing load sharing. You can do load sharing for under $100. Load balancers are where we start getting into sometimes 6-digit products. Like a cheap F5, a virtual F5 is something like $30,000. And then you need a pair of them, and then you need a support contract. It's 50, 60, 70 grand in software by the time it's out the door, depending on what your functionality is. Load balancing is much different. What we're doing here is load sharing. The good news is it gives us redundancy that we had before, except convergence is going to be much, much faster. Spanning tree doesn't need to reconverge. OSPF doesn't reconverge. If one of these links was to fail, that's still the best path to the root. We just went from 2 gigabits per second down to 1 gigabit per second. That's all that happened. So redundancy is still there. We've got faster convergence because it's seen as one logical port to spanning tree. So to set up a port channel between two devices, it could be negotiated. We've got protocols that do just that. They negotiate port channels. One was created by Cisco. It's called PAGP, which is port aggregation protocol. And there's LACP, which is link aggregation control protocol. This is a standard. This is Cisco proprietary. Now, me personally, I've been doing this for a lot of years, and I absolutely love Cisco. They're not without errors. They just, in my opinion, have less errors than some of the other vendors, and they're a little bit more responsive to customers. That's my opinion, and that's everybody's got one, right? However, here comes some real logic. As much as I say that I love Cisco, I would recommend that you try not to run Cisco proprietary protocols if you don't have to. A lot of people say, well, don't run Cisco proprietary. Oops, I'm going to come back. Let's bring this up for a second. I'm going to stop touching buttons while I explain this. A lot of people would say, don't run Cisco proprietary protocols because of vendor lock-in. If you do Cisco proprietary now, you've always got to buy Cisco. That's a terrible answer. We already saw that like HP and Dell, they can do CDP. EIGRP, which is Cisco proprietary, is open as a standard, so other vendors can do that now as well. My reason for you not to do Cisco proprietary, try to avoid it if you don't have to, because not everybody does it. As a matter of fact, no one should be doing it besides Cisco. And here's the messed up part, and this is kind of the key to the logic. Where does Cisco get most of its new products? If you saw an announcement today, if one of you just now made a correction and you said, Ryan, think you're wrong. Cisco does have a load balancer. Where did they get their load balancer from? Did some scientist shout out from the lab that the load balancer's finished? Mark already saw where this is going. Acquisitions. So when Cisco acquires another company, and that's where they get most of their products from, through acquisitions, those acquisitions don't speak Cisco proprietary languages. So I see customers that go, we run Cisco proprietary protocols because we only buy Cisco. We're a Cisco shop. And they feel like they're jumping in with both feet. I go, here's the thing. You have to understand why Cisco has proprietary protocols. If there's a standard out there and it works, Cisco doesn't say screw the standard and do their own thing. It's when nothing is out there and nothing works, and the customers say, Cisco, blah, 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 blah. We have this pain. There's this thing that we want to do and it doesn't work right. They know that a standard is going to take 10 years to come about because you've got all these people on this really long, slow deadline. They're going to debate like politicians forever. They go, you know what? That's a good idea. We're going to grab these 4 engineers because you're a big company and we're going to get to work on this. They crank out a beta, you test it, they crank out basically a new version of code, and then we get the feature as an update. And they go, okay, well, we just created this, we documented it, other people are finally one day, like in the world of CDP, 12 years later there was a standard. They go, when there's a standard, we'll totally support it. But until then, we're doing our own thing. Cisco created BGP, they created PAGP, they created Cisco Discovery Protocol. A lot of the protocols that we utilize, NetFlow, they created, they made it up, and then later a standard comes out and then they support it. So give credit where credit's due. They do create a lot of things, but once a standard comes around, it's best that you stick to the standard. So here's an example of why. PAGP can be found on Catalyst switches. Catalyst. LACP can be found everywhere. What do I mean by everywhere? Well, here's a switch, and here's another switch. And I'm going to create a port channel between them. So you know that we can create port channels between switches. What else might I create a port channel to? You guys give me some ideas. Like we talked about yesterday, we've got trunk links between switches, but you could have trunk links to other devices. LACP is a standard. Microsoft can do LACP. VMware can do LACP, which means I might have 2 NICs in my server, and I created an LACP bundle. When I connect to my ASA firewall, and I bet some of you guys have firewalls, I can do an LACP bundle. Depending on the type of router that you have in the code, you could do an LACP bundle to your router. So LACP is supported all over the place. Once you jump, if you guys ever make the leap from, this is the standard path of CCNA routing and switching, if you ever go CCNA data center and you start to learn about Nexus, Nexus only supports LACP. So you're going to find other Cisco products that only do the standard and that don't do the older style. That's where I said get comfortable and get used to doing a standard whenever possible. Nexus and UCS both. This is Cisco's server line. These were both acquisitions. So you go, okay, we get it. Cisco does a lot of acquisitions. And I go, well, don't get the wrong idea. Is it that Cisco doesn't create anything themselves? That's not the case at all. They're doing tons and tons of R&D. They've got a bigger R&D budget than most other tech companies. That's why they create so much. But they also know that they're a massive company, tens of thousands of employees. And how many of you have worked for a small company versus a large company? Has everybody at least spent a little bit of time in both? Thumbs up if you have, thumbs down if you don't know what I'm talking about. In a small company, how hard is it to get something done? If I have an idea at Stormwind and I go to my boss, tomorrow I can blaze on that idea full speed with extra resources. When I get to a large company, if I worked for HP or Cisco and I had an idea for a new protocol, it might be a year before I had approval. They know that. So Cisco does something called spin-ins. This is where they give money to a team of engineers to do a startup. They go, here, run in your own little incubator. Come up with the idea. We're going to check in on you. If you're still on track and it looks good, we're going to continue your funding. And once they're done, they get gobbled back up and become part of Cisco. They say, go work over there in that office of 20 people with an insane deadline and put in 80-hour weeks for the next year. And just go. Skip the meetings, skip the policies, skip the procedures, and just get the product done. Once the product gets done, we're going to qualify it, and then we're going to spin it back in. NXOS or Nexus and UCS were both part of spin-ins. So again, they acquire a lot of their technologies. Some are just completely different companies, but some are actually companies started with Cisco funding that Cisco winds up buying back in later. All right, so Etherchannel protocols, that's enough about acquisitions and standards and being proprietary. There's different modes that you can run in. PAGP is the one that I recommended that you don't use, but there's different modes to build an Etherchannel. So let's talk about that real quick. Here's my two switches. I want to bundle these 4 links together. I have 3 options. I know the class is saying that there's 2, and then they like talk about different modes, but it's really not accurate. You've got 3. One is that you can use LACP. 2 is that you can use PAGP. And 3 is that you can do what I'll call static. So static is the easiest one to understand. I go into each switch and I say, hey switch, ports 21 through 24 are in a port channel. That's it, you're done. On this side, ports 21 through 24 are in a port channel. There's nothing to talk about, there's nothing to negotiate. That's just how it's going to be. That's static configuration. It's quick, it's simple, and it works. I dislike it compared to LACP, however. I prefer this. And the reason for it is if one of these wires gets moved somewhere else, the switch may not necessarily know that. So if there's ever a misconfiguration with any of my wiring, he's not going to detect it because there's no diagnostic messages being sent. If something was to fail, I'm normally not where this switch or these wires are. I'm across town, I'm in another state, I'm working from a remote office, so I can't see this to troubleshoot, and the show commands may not show me a whole lot. With LACP, a link is dynamically negotiated. So sometimes the negotiation could fail. That's why people would say static is better because it never fails. I only see LACP fail when I initially set it up, and if it doesn't come up right, I turn it off and I turn it on again. Not the switch, just the physical interfaces. That's normally enough to bring it up. Once it's up, LACP protocol data units are sent, and I can do good juicy show commands, and I can get lots of information about what's going on with my port channel, so that if I do have problems, I can troubleshoot much, much easier. If I ever have to troubleshoot this, I'm clueless because there's not diagnostic messages. I can still use CDP and I can still use MAC address tables, but it's not as good, at least in my opinion. I prefer LACP, and I never use PAGP. I know what it is for the test, but that's about it. So PAGP is like LACP. It's Cisco proprietary, and it has 2 modes, desirable and auto. Desirable says actively ask the other side if it wants to participate. So imagine kids at a high school dance. One side wants to dance, the other one will dance if someone asks it. So in other words, auto is the passive kid at the high school dance. How does this affect us as administrators? Well, if I set switch A to auto, which is the quiet kid sitting on the corner, sitting on the bench, and another quiet kid sitting on the bench, they are never ever going to dance. It's a goofy analogy, but does that make sense? And if I go desirable, this is somebody who's looking to dance. They'll ask the person that's sitting down, and they'll find other desirable people that want to dance. And then alternatively, you can just hard code it to be on, and then it will work. So on refers to static configuration. There's no protocol, there's no hello use, there's nothing to talk about. With PAGP, at least one side needs to be desirable or it will never come up. Any questions on that? All right, looking at LACP. All right, I appreciate the thumbs up. Let me know you're doing good. With LACP, this is Link Aggregation Control Protocol. This is the standard. This is what I can talk to access points and other vendors' switches and servers and firewalls, you name it. Once again, they're showing on here as a mode of LACP. That doesn't really accurately indicate what we're doing. Just realize there's 3 options: static, LACP, and PAGP. And what they're saying here with LACP, there's 2 modes, active and passive. And if you use the little analogy with the kids at the dance, the 2 passive ones are never going to get dancing. But if you have an active, talking to passive, it'll work. Active, talking to passive, it works. Active and active, yes. Or you could statically configure it. That really didn't need to be in both tables. All right, so in order to form an Ether channel, we need a bunch of ports, and they should be the same types of ports. They should be copper or they should be fiber. Some devices let you mix, but there's actually different mechanical properties that have to deal with the serialization of data onto a wire, whether it's wire or fiber. And it is recommended to use the same type of connectivity. Some devices won't let you mix, others will, but try to make it match on both sides if you can. The type of media and ports, the speed and duplex, the mode, whether it's access or trunk. If you've got anything going on with your native VLANs or you're restricting what's allowed on the trunk, it needs to match on all the physical interfaces as well. To configure an Ether channel, it's pretty straightforward. We say channel group and we give it a number. This is your logical interface ID. Over here, the mode sets how you're running. So let's just take a look at this, and I think it'll make more sense. The slides are fine for learning the concept, but then you go to configure it, and it can be a little bit messy. Let's go into interface gig 10/15, and I can say channel group, and you just give it a number, 1 through 48. This switch will allow me to have up to 48 Ether channels. Well, I've only got 48 interfaces, so that's pretty good. I guess I could have stacked it and maybe had some more, but whatever. Let's go ahead and say we're going to create channel group 2. And the next thing I have to set is mode. They're saying, what type of Ether channel is it? This is where I said you have 3 types. You can set it to on, which is hard coding it. There's no negotiation. We could say passive, which is passive LACP. If both sides are set to passive, it won't work. I could say active, and that's what I normally do. Channel group 2 mode active will enable LACP unconditionally. He's trying to ask the other side. And then you basically have the terms desirable and auto, which are really like active and passive respectively. Auto is like active. I'm sorry, desire is like active, and auto is like passive. Does that make sense? So those are for PAGP. The top and the bottom are for LACP, and on is for static hard coding. That's all there is to it. So you could put interfaces, let's say ports 35 and 36 into a port channel. I could say channel group, I'd go into each interface, right? Let's just bring up Notepad. I'd say interface gig 1/0/ let's say 21. And I could say channel group 5, mode, active, and then I can go to my next interface. And I could use the same command. Is this making sense? So that's what it would look like. And those 2 physical ports would be under the logical interface of 5. They would be bundled together. Cool. Once you have it configured, you can treat this like a normal interface. I would say interface port channel, and in my example, I could say 5, and then I could say switch port mode trunk, and I could say which VLANs are allowed. So you could set up your port channel. Reggie says, doesn't it make sense to configure the interfaces at the same time? So I think Reggie's saying I could go in and I could say interface range gigabit 1/0/ say 18 through 21. And then I could just put the command here and do it all in one command. That would make more sense, but I was just trying, I think so, but I was just trying to illustrate what was happening on a port by port basis. But if you're, Reggie, you're a step ahead, so that's okay. It's good that you're looking at that and you go, you know what, there is an easier way to do that, and there absolutely is. I was just trying to illustrate. So in what I said, I would have had to say like interface 18, 19, 20, and I would have had to put that command under each one. So interface range definitely speeds things up. And that's what they were doing here. Interface range and you specify a range of interfaces, and then you can configure it like so. All right. So verifying the Ether channel, you can do a show interface port channel 1. We see that it's up and up. You can do a show Ether channel summary. This is why I like LACP, because you'll get messages about the ports. You say, these are the ports that we're connected to. This is what's going on with them. See, we've got a P, so it's bundled in a port channel. If it was suspended or if there was some type of error, we could see it with the show commands. Just for me personally, it's made my life less frustrating in the past when it's been there. If we do a show Ether channel port channel, I hate looking at screenshots of commands when I've got hardware right here. Let's just go over here and say show Ether channel port channel, and I think I can say 1. No, I can't. So that command is just going to create a list. So if you got multiple port channels, there's no quick way to get there. Maybe you could begin at the port channel that you want. So here we've got one group. The port channel is called port channel 1, and we can look here and we can see the number of ports is 2. We're using LACP. There is no port security where you filter on MAC addresses. If we look down here, ports in the port channel, we've got 23 and 24. Time since last bundled, 289 days. So this has been, I don't think I've been in the house that long. So this has been going for a while now. So this is just what we can do. Yeah, you could pipe it to begin or include, exactly. So if I had like 14 port channels and I wanted to begin at 12, I could say show port channel, and then I could say begin PO 12, and that would get me there. Yeah, good. I love when I say something, I'm like, I couldn't do that, and you guys are like, yeah, here's a command that would work. Good minds. So that's Ether channels and LACP, and we talked about why we like them. Layer 3 redundancy is where we should pick up tomorrow. That's going to get us into HSRP and VRRP. So before we split for today, I want to show you guys about stacking. Stacking isn't something we need to know for CCNA, but it's something you need to know as a network engineer, someone who might be involved with purchasing hardware, or you might be working on a mid-size environment. Stacking is the ability to take 2 devices and treat them as one. So for instance, I could have 2 Catalyst 6500s. Those are big modular switches. And I could bundle these together with a technology called VSS. This is virtual switching system, and it allows these 2 switches to appear to be a single switch. What does that mean? Well, I could log into a single device and manage it. If these 2 switches were going to be OSPF neighbors with a router, maybe here's my edge router, I could have one adjacency. You'd have a virtual IP address like .1, but you would have 2 devices supporting it, so that if one device fails, .1 is now available over here, and let's say that this is .2, and .1 would always be reachable. So, right, Todd, it's like a master-slave scenario where one is active, the other one is standby. The super cool thing that this leads to, though, is multi-chassis link aggregation. Let me show you what I mean. We've got these layers. We've got core, we've got distribution, and we've got the access layer. When you get to your access layer switches, remember how much cross-connectivity there is? And we all have spanning tree on the mind, right? So from a spanning tree perspective, a lot of the ports have to be blocked. We can do some things to try to get load sharing going, but unfortunately there's typically a lot of blocking. So a sample topology from, let's say, server, I'll just put SCR there, to access layer switch distribution may look like that in terms of cabling. We know based on our spanning tree knowledge at this point that spanning tree is going to block a lot of those links. Yes, we can get load sharing, but only through the use of multiple VLANs. How can stacking make our life easier? Well, the VSS, virtual switching system, allows me to stack these 2 6500s and make it appear as one switch to downstream devices. What does that mean? Well, from a spanning tree perspective, there is going to be one bridge ID for the stack. So the master device, he'll have a priority and he'll have BPDUs, and they're going to be coming out of all the links. So if I was to do like a show CDP neighbors from the distribution devices, it looks like there's 4 links going to the same place. And mark, that's where this is headed. At the distribution layer, if I've got the right supervisors in my 4500s, I can do VSS here as well. On 3750s, the 3750X is a stackable switch. So if I've got 3750Xs, I can stack these together. And this just now went from being 2 48-port switches to one 96-port switch. I've got one IP address to log into and manage 96 ports. And you know what? I could add another 2 switches, and another 2 switches, and another 2 switches. I could put 8 switches in this stack, log into one device from PuTTY or mRemote, you know. I've got one IP address to remember, and I can log in and I can hit hundreds of ports. I have the port density of a 6500, but I've got the ability to start off with a single 3750X and buy another one in 3 months and buy 2 more in 6 months. And I can slowly build this and then manage it like it's one big switch. What makes this so cool is when you go up to your 4500s, once again, these are going to be treated as a single switch, which means we can use link aggregation control protocol. Do you guys see where this is headed? Because they're sharing common bridge IDs for their protocols, this can now be an Etherchannel. And this can now be an Etherchannel. Do you guys appreciate that? And see, Todd says we stack 4 3750Xs where I work. This is why we do that. A, it's nice for management. I can log into one device. You know, I can SSH in and I can see all my switches. Each switch will have a different number. So like on my 3750, I keep talking about port 1/0/15. Well, if I add another switch, that becomes switch 2. And port 15 on that guy is 2/0/15. And if I add a third switch, it's 3/0/15. So if I log into like, I'll show you. If I log into a 3560, this is not stackable. So in a 3560, see my interface numbering? It's just unit 0 and then port 1. Over here, on my 3750X, show int brief, show IP interface brief. Show brief interfaces on Nexus. What we see here is that this is switch 1. Well, the next switch would be 2, then 3, then 4, and I can manage all my switch ports from one single SSH session, which is awesome from an administrative perspective. But over here, from a management perspective or management protocols perspective, LACP is a shared process between those two devices. They know that same bridge ID, so we can have an LACP bundle here and an LACP bundle here. Once again, if you're sweating right now, this is not on CCNA. This is not an ICND 1 or 2 topic. This is something that's going to be in the NP switching class, but doesn't exist there yet. But I'm telling you because you might have this in your environment. Most customers I come across are using VSS or using 3750s. If I've got Nexus here in the data center, they don't really stack, but they do support something called virtual port channels, which is a federation where they pretend to be the same device, so you can do that to them as well. And Eric says we have this all over our environment. Okay, awesome. So I just feel like you guys should know a bit about this because you're probably going to see it. Mark says, how would you Etherchannel port 22 and port 22 on the switches? Oh, let's say I was going to use, this would be like 1/0/22, and this could be 2/0/22. Nexus works a little bit different, but basically that's what would be going on. Each of your line cards gets a different number. And then you'd put those into port channel 5, and then this is port 5 logically. And what's so awesome about this is you go, oh, hey, look, it's 6:59 p.m. Eastern time. We've still got about 40 people working in the office. What the heck? I'm going to reboot this switch right now. Could you imagine that? Just going to a distribution layer switch while you've still got 50 people working in the office and rebooting it? This could cause spanning tree topology changes. It could cause OSPF adjacency changes. Mark's laughing. He's like, yeah, there's no way. Well, this gives us the ability to do what's called in-service software upgrades. Now, me personally, I'm still going to do this during a change window in the middle of the night. But theoretically, I could do a software upgrade, or I could lose a switch. And guess what? From access to distribution to core, from spanning tree, this is all he ever saw. I might have 8 or 9 3750s. I might have 2 to 4 chassis-based switches. The number of switches that you can stack vary based on which model and which version of code. Originally, it was only 2. Now, in some scenarios, I've seen up to 9. But I can have one of those devices drop, and it's not a problem at all. LACP fails over faster than anything. He sees a link go down, he upgrades his load sharing algorithm, and he says, hey, quit using port 1. Port 1 just went down. You're talking of a failover time in many scenarios in less than 5 milliseconds. If I wasn't stacked and you're waiting on spanning tree is said to work somewhere around 50 seconds, and there's a lot of things that could cause it to go longer. So we went from a 50-second failure time to somewhere between, in most cases, 5 to 50 milliseconds. And there's other switches and other technologies that can do it even faster. But for the most part, what I see on most vendors with their stacking technology is somewhere between 5 to 50 milliseconds of latency. Or in terms of, and I say latency, the event occurred and we've corrected it. And again, this simplifies things from spanning tree because you've got similar bridge IDs being used, and we've got LACP. So just like before he saw a single path in a bundle, it's a single path in a bundle. This is what spanning tree sees. It would be like 3 switches, even though it could really be 12 switches. So again, as a concept that's not on the exam and not really in the class, just kind of like a value add, does this make sense? There's a 94-page document on doing VPC on Nexus 7000s that's relevant to that version of code. So I'm not going to lie, there's some more to it, and there's some things you have to think about when you plan it. But for the most part, this is what it is, and this is why this is a big, I think, decision, kind of, because something that would influence your decision when picking a particular brand of switch. How does their stacking work? And different vendors have got different stacking solutions. So this is what stacking is, and this is why you do it. Super cool. So you guys are doing great. We should feel good about spanning tree. Link aggregation, in my opinion, that was the second portion of our class. It didn't have a lot to it. We said we're going to bundle these links. It simplifies spanning tree. We can fail over faster. We had the 3 modes, static, LACP, and PAGP. We described those, and if I were you, if I was an attendee of the class, I don't know. It'd almost be like if you eat a dinner and you pick something too small. I'd go, is there dessert? Are they gonna bring a coffee? I'm still kind of hungry. So if that was your mental state, I hope this made it feel a little bit better. And if it didn't, if you're still hungry, if there's something that you want to know about, I'll happily stick around and we can chat. Otherwise, that's going to be a wrap for today. Thank you guys so much for joining me, and I look forward to seeing you all tomorrow. All right, Reggie says makes sense. Very cool. All right, good deal.